Hello everyone, today we're going to look at standard deviation. So standard deviation, which is denoted by sigma or sometimes S, depending on if we're talking about the standard deviation of an entire data set or a sample of data sets. We're going to assume we have the entire data set, so we're going to use sigma. So this is a measure of variation. And what that means is it tells us how spread out our values are. So let the numbers in the dataset be represented by x sub I, so x1, x2, x3, up to xn, where n is the number of values in the dataset. Recall from before when we talked about mean, median, and mode that x bar is the mean of the dataset. The standard deviation is found using the following formula. So it's the square root of the averages of the squares of the differences of the values with the average. So it looks a little complicated, but we're going to kind of break it down and hopefully kind of do it piece by piece so that it makes sense. So I like to use a table to keep everything organized. So first, let's find the standard deviation of the following values. So 5, 9, 12, 7, and 7. So I'm going to make the following table. We're going to have in our first column the x values. So I've just listed them, 5, 9, 12, 7, 7. Then what we're going to do is below it in my last column, I'm going to put the total. So if I add up all those numbers, I get 40. So then we're going to use the formula for mean to find the mean. So remember that the mean is the sum of the values, which we just found, divided by the number of values. So x bar is 40 divided by 5, which is 8. So then what we're going to do is we're going to take the value and subtract 8. So 5 minus 8, 9 minus 8, 12 minus 8, and so forth. So that's going to give us these values, -3, 1, 4, -1, -1. Now to make sure that we're doing these correctly, if I add those values up, so if I find the sum, every single time it should be 0. And if I add up those numbers, I do get 0. So it's important that we're really doing the subtraction in the same order. So again, if we notice the negatives add up to -5, the positives add up to 5, so we do get a 0. And again, that's what we're going to get every single time, just by virtue of how x bar is defined. And then the last column, which is the numerator of that square root of the formula, is going to be adding up the x minus x bar squared. So we're going to take this number and square it. Now remember, a negative number squared is positive, so none of the numbers in the last column should be negative. So I get a +9, +1, 16, 1, and 1. Okay, so we got no negatives. We add those up, and we should get 28. So now the formula for sigma, the standard deviation, is the square root of 28, the sum, divided by 5. So that's the square root of 5.6. And then we're going to round this to, say, the nearest hundredth. It's not usually going to be something nice, so it's roughly 2.37. So the more spread out the values are, the larger the standard deviation will be. So this is a fairly small standard deviation, but we also don't have many points. But we're not going to do it with too many points because then it just gets complicated when we're doing it by hand. So let's do it again. So we have 10, 15, 20, 20, 25, 30. We want to find the standard deviation. So again, we're going to fill in that same table. So again, the first column is just the values listed, and then I'm going to add them up, and we should get 120. Then our x bar is that 120 divided by how many values we have, which is 6. So our average is 20. So in our next column, we're going to take the x values and subtract 20. And that gives us -10, -5, 0, 0, 5, 10. And then again, if we add those up, we should get 0. So it's a good way to check halfway through it that we're doing it correctly. And we do get 0. Now that we have 0 there, we know we're good to go so far. So again, we're going to take that middle column and then square it. So we get 100, 25, 0, 0, 25, 100. Add those up, and we get 250. And then we're going to use the formula. So we have that it's the square root of 250 over 6. And that gives us 6.45. So that tells us that these values are more varied than the previous one. Find the standard deviation of 200, 180, 190, and 30. So notice that 30 is a lot different from the first three values. So we're thinking that this standard deviation should be a lot higher because they're more spread out. So if we remember from mean, median, mode, 30 could be considered an outlier here depending on what it is that we're finding values for. So it will change the mean quite a bit, and in that respect it will also change the standard deviation. So the standard deviation should be fairly high for this. So again, we're going to start by listing our 4 values, and then we will add them up. If we add them up, we get 600. So x bar will be 600 divided by 4. So that is 150. So we're going to take our values and subtract 150 from them. That gives us 50, 30, 40, and then a really big negative 120. And we want to double check, do those numbers add up to 0? And they do, so that's good. So then we will start squaring those numbers, and those numbers squared are going to be fairly big, right? 50 squared is 2,500, 30 squared is 900, 40 squared, and 120 squared. So we can see these values here are getting really big really fast in this case. We add them all up, we get 19,400. So our standard deviation is the square root of that sum of the squares divided by n, how many numbers we have. So the square root of 19,400 divided by 4, square root of 4,850, which gives us 69.64. So this is much higher than the other two, again, because that 30 makes it a lot more spread out than before. And then finally, we'll do one more. So we're going to have 1, 2, 1, 2, 3, 4, 1. So again, we'll list all of those values and add them together. If we do that, we should get 14. So our x bar is going to be 14 divided by how many numbers we have, which is 7. So our mean is 2. So we're going to take each of our x values and subtract 2 from them. And that gives us negative 1, 0, negative 1, 0, 1, 2, negative 1. So they're all very small. So we should get that our standard deviation is going to be a much smaller value. If we look at our numbers, they're all spread out between 1 and 4, so they're all fairly close to each other. So then we want to double check that we did this correctly, so add up all of those values. And we do get 0, so that's good. And then we're going to square them. And we get 1, 0, 1, 0, 1, 4, 1. We add all of those up, and we get 8. And then again, the standard deviation will be the square root of that 8 divided by the number of values. So we get the square root of 8 over 7, which is 1.07. So again, the standard deviation is much smaller. These numbers are not very varied. They're all fairly close to each other. Okay. So that's it for standard deviation. Let me know if you have any questions. Thanks.